And Dr. Allende asked me to speak today on Pierre. I think that many of you know Pierre. He's a physicist, astrophysicist, professor emeritus of the University Paris de Boulogne, and very much involved in the conception of the VLT that works today in Chile, member of the Academy of Science in France, and various others around the world. Co-founder of Le Maire de la Patte, and is clearly one of our main guests in this program on science. The rest of the information is on the internet, so. But basically, and I thank the doctor very much for having asked me to do this introduction, because I don't know if it was about 10 years now already, but when the program began, the EGBI program, or La Malapat in Chile, this was in the district of Cerro Navia, located in Greater Santiago, one of the poorest areas of Chile. And at the time, I was the mayoress there. I was mayoress for 14 years. And at the time, I managed 24 schools. When we began the EGBI program, Pierre Léna came to Cerro Navia, and I welcomed him and heard one of his classes. He gave one on science. He spoke of science. And I was so surprised by the simplicity and the warmth with which he addressed people. And one of the things that he said, I also attended a conference that's on the internet in French, a lecture called La science, une belle province de la culture. Science is a beautiful province of culture, and where he makes a very interesting analysis of the relationship between science and culture. And at some point, he said something that makes a lot of sense to me, and made a lot of sense to me also while I was the mayoress of Cerro Navia, and we're very much related to education. And he said that education is an act of generosity. Education is an act of generosity in the sense that educators relate to children. We give ourselves to children and together build their future and their coming. And he says, although we do 10,000 programs and change them another 10,000 times, we will never change the relationship between the educator and the child. And this issue of the connection is very important. I would like to read to Pierre Léna a quote that I read to him when he came to Cerro Navia more or less 10 years ago. It is a quote from a book by Boris Ulnik, who is a psychiatrist, a cytologist, and has done a lot of work on child development. He works on affection, attachment, and mistreated children. He coined the term of resilience. And he says as follows. I will read to Pierre in French, because so I read it to him 10 years ago.
Un univers privé d'autres me laisserait seul avec moi-même pour toute rencontre. Toujours le même, sans surprise, sans émotion. Jusqu'à la routine, l'engourdissement et la non-vie avant la mort. La rencontre crée un champ sensoriel qui me décentre et m'invite à exister. Lo voy a leer en español.
I will now read it in Spanish. She says, because she said I'm told that there's no translation from the French, and it says, a universe without an encounter, a universe deprived of the others would leave me alone, with myself, as the single encounter, always the same one, with no surprises, with no emotion. Even routine and sleepiness, and non-life before death. Meeting creates a sensory field that invites me to exist. I believe that is what teachers do when they relate to children. They invite them to exist. And I think this science program, which is this meeting that we're having today, also invites us to a new form of relation, not only between teachers and children, but the human being and the world, nature, how to understand nature. I would like to show you an image. I'm sure you've seen this on the internet, yes? It says ego and echo. Ego, man is up here. Below, women and whales. And at the bottom, certain mollusks. That vertical, pyramidal arrangement is what I hope we're able to change, and I think we can with this program. This different form of relationship, man, women, and mollusks, we're all in the same bundle. We feel solidarity intrinsically. And I believe the only way of really teaching solidarity is learning with an ecological viewpoint of the world. And I hope this program helps not only to learn science, learning how to think, develop ideas, speak, write, as has been said here, that improves so many other areas, but also relating to the world in a different way. When I met Pierre Léna, he transmitted that to me. When he gave that class in Cerro Navia 10 years ago, he transmitted that possibility to me, and that is why I feel so proud to introduce him today, and I hope that with these programs that they created and proposed, I hope that we're able to change our approach of the world and have, as he says, a new hope in the future. Thank you.
Thank you, Christina, for those excessively kind words. And I'm very happy to be with you here tonight. I'm going to speak about those 21 years of La Main à la Pâte that we worked very hard, first at the French Academy of Science, and then in a foundation which was created 4 years ago. And the president of the foundation is Daniel Rouen, who is here, and many of you have met him already. Of course, I'm trying to extract the best of this time of 21 years, but before, I'd just like to remind Egby, we were a bit younger, except Christina, who didn't change. In Cerro Navia, that was more than 10 years ago. The plan I'm trying to follow is to give this some abstract of what we have learned for those 20 years in France, which has some characteristic of a developed country, but also some universal characteristic for science education. Then I will move to what we have learned also from the various international cooperation, and then I will question this motto, school as usual, which was already addressed several times in the day. La MAP, in 1995, we elaborated simple principles, which were not called IPSE at that time, but it was much more than hands-on the impulsion of Georges Charpak, who had received his Nobel Prize in 1992, in physics and was decided to devote his own fame and time and action to children in schools, feeling that he had himself a debt to the French schools who had accepted him when he, with his family, escaped the anti-Semitism in Ukraine and came to France at the age of 9. So the principles were simple. They have been repeated today. Of course, one can discuss the details. I think one of the most important points, and the newest one for the French schools, was involving the scientists and engineers. The understanding of, say, the Ministry of Education and also the scientists at the academy was that getting into primary school science was, there was no need for scientists for that. It was simple science, simple sentences, and so why do you care about that? And the other idea was that we wanted to open the school to parents and local communities. We had actually a long-term goal, not only have some pilot project, but in France there is about 350,000 teachers, K5, 7,000 middle schools, 6 to 9, and the aim was to change all of that, which was a lot. And we started with K5, and then about 10 years later we began to address the middle school. And the methodology was rather clear to us. We didn't want to do things in a kind of quasi-static, I speak as a physicist, a transformation, where you have a stage and then you move a little bit to the next stage and a little bit and you hope to reach a very different stage from that. We wanted to introduce ruptures, very clear ruptures from the school as usual system. And this was, of course, difficult, and the only place to do that was to use the independence of the academy and the prestige, because the ministry had to listen to Charpak and also to the academy work. And the idea was to implement prototype in limited areas to demonstrate they were working, and then to propose to the ministry extension of those prototypes. It was their responsibility, not ours. Of course, to do that, one had to look for quality and for quality resources. So not only those resources should be free and good in science and pedagogy, but also easy to access. Fortunately, Internet just emerged as a fantastic facility at that time, because otherwise addressing over 300,000 teachers was essentially impossible. The idea was also to count on contagion. Charpak was often using a medical example of contagion of disease, dissemination by one or two teachers in a school being so enthusiastic and the kids so happy and the parents so interested that it would progressively disseminate. And this has worked not too badly. And then the rupture should inspire big changes, in-depth changes of the public system. And finally, this point of working with the scientific community. I think this methodology has been followed since the beginning and still is today. So we, along those 20 years, we consider several different ruptures, different in aim, different in context. The first one was primary school, because primary science was essentially abandoned in primary school. So we had to reinstall it with inquiry and make clear that it was possible and that the teacher could do it. The second rupture was integrated science in grade 6 and 7 in middle school, where science was already broken into disciplines with strong walls between them. So this started about 10 years later than the first one. Then, of course, both goals, both ruptures, which had to be accepted by the ministry in a prototype form, were intimately related to the in-service development of teachers, as it has been said repeatedly today, from K9 essentially. So the third rupture was to introduce a completely new initiative on large-scale in-service professional development of teachers, and I'll describe that. And today we are thinking of a fourth rupture, which is to dedicate, and I will not speak about it because it's not funded yet completely, to introduce in middle schools, this is 6th to 9th grade, pilots middle school in science and engineering in a completely interdisciplinary, integrated way. So let me first describe you the first rupture, and it's the end of the day. So I want to show you a very short movie which was won by a class of grade 1. So those kids are 6 years old, which demonstrates, and I often use these movies in talks, the remarkable cognitive abilities of young children once they are motivated to do it. So this is the movie. I don't ask you to stand up, but I show you the movie and I will simply make a few comments. So please, can you play it? So the name is A Mouse in the Labyrinth. And the challenge for children is to build a labyrinth with the mouse at one end and with the food at the other end. So they have all steps given the problem given to them. This will last about 6 months to conceive the labyrinth, understand what it is, design it. This is some technology, 6 years old children, you see? So then they will build it. They first draw it on the computer, examine the possible path. Then they build it in foam, in polystyrene foam, very carefully according to the drawings, taking the measurements. And then when they have finished the construction, they will observe the mouse and measure with a camera, which is on the top there, and a watch, which is filmed by the camera. They would follow the path of the mouse. Here is Mimi the mouse, trying to find the food, which is at the bottom right of the labyrinth. And you can see, and the time is shown. And now, why is not the time showing? The first attempt, the time is 3 minutes. It's written there, it should show up. And then they will repeat that 6 weeks after 6 weeks. And you will see the time. The first time is 3 minutes. Now it's 2 minutes. The next one, I think, is 1 minute. And the last one is, and this is not accelerated, and the last one is 7 seconds. See? And so the question is now, can you analyze those data? So you see they make a table with all the numbers, and then of course they will make a graph which shows the time versus the time elapsed since the first trial. And you see the spectacular decrease of the time for the mouse to reach the food. And then the question, and they will discuss, of course, why is that, proposing hypothesis. And after a long discussion, 2 ideas come up. One, it's because the mouse remembers the path. And second, it's because the mouse has left some chemical along the path, and progressively she recognizes the path by smelling. Now, how? Is she following her previous tracks, or does she remember the path? Okay, then they will design a new experiment which ends up by being the same labyrinth, being all rebuilt again without possible track, and then experiment what the mouse will do. And so they are very eager, of course, to see who is right. And the class is about divided. So they will experiment again with an entirely new labyrinth. And the result is very impressive, because you see Mimi clearly will do, I think it's You can see now this is 7 seconds. So it's exactly the time of the previous one. So now they will conclude that Mimi has a memory, that she has trained her memory. It took that time to train. So it's a very nice neuroscience experiment which children, of course properly guided, are able to do at the age of 6. And this, if necessary, but here we don't need to be convinced, is proving that their brain can work probably as well or even better than Mimi's brain. Now, in this first rupture of la main, la patte, we obviously realized that teachers were the key of the change, and we did a lot of research on the time necessary to convert, in the sense that a pilot from a Boeing 747 has to be converted to an Airbus 340. He has to learn a number of new things before to be able to drive this new plane. Now, how long does it take to convert a teacher? And our conclusion was twofold. This time is long, minimum 3 years of practice. And second, it needs support. It cannot do it alone by reading books. So the support has to come from various setups, accompanying people, young scientists, of course, document. And interesting enough, the time to the performance in reaching the several goals of inquiry are different. Like the going from individual experiments to a structured knowledge, which is of course the thing the school should aim at, not only pieces and bits of knowledge, but something which is structured, requires much more effort than, for example, writing and communication, which is something teachers are used to. Now, I don't go much more in this because I just want to mention to you one recent action in this primary school in IPSE, which is to develop some modules and activities for handicapped children, either motor handicap or mental handicap or behavior handicap. And this is incredibly successful, to the point that we have published a small book, and hopefully will be translated, which is how to behave in a class with heavily handicapped children who become very interested by science, even if it's difficult for them to do the experiment, even if it's difficult to communicate and discuss hypotheses. This is a classroom in Toluca, near Mexico City, where we had a partnership with this, and I was in this class. It was absolutely extraordinary to see the intensity of attention of those children. Now, the rupture number 2 was in middle school and was to create interdisciplinarity. We became very modest with 10 middle schools. Now we are close to 200, where we tried to break up the walls which were separating physics, chemistry, specialized teachers from life and earth science teachers and from technology teachers. And they are all against us. We had to convince not only the inspectors, the ministry, who finally accepted the pilot project, but also the teachers themselves. And the principal was very rude, and in this sense it was a rupture. They had, and we accompanied them, of course, to work together and to elaborate a single course for 1 year long, where each of them would teach the same thing, including the 3 subjects, which means that they had to learn the other subjects. And this was very new to them, because some of them were there for 10 or 15 or 20 years of practice, and they were just repeating, as Bruce was saying this morning, the same thing. And suddenly they had to learn science, maybe biology, like the kids they were asking. And suddenly they were discovering that it was not so simple. It was not sufficient to speak about parenchyma or cells without explaining the words, because themselves they had difficulties. So it was extremely interesting for us to see them forced to learn a new science, as we scientists, we have to do every month or every year. So this has inspired the national reform, which the French government has started for next September, which is very ambitious and which aims at introducing in middle school interdisciplinarity during the 4 years of grade 6, 7, 8, and 9. And students will have to choose 6 interdisciplinary modules, and I just gave some examples of the titles suggested by the ministry for those interdisciplinary model, which obviously will have to mix the 3 scientific disciplines. Math is not part of it because the math teachers thought they were by far superior to the natural science teacher, and they would not like to join that. Now we are working in this new frame of the reform to include the math into the science sort of kind of integrated science and math part in middle school. So we are happy to see that the rupture is accepted by the ministry and made general. On the other hand, we know very well how much effort is necessary to transform those teachers, and we'll see what happens with the grandiose plan of the ministry. We'll try to help as much as we can. Now, this is interesting because this is a very good quality study which was made by the ministry independently of us, trying to compare the teacher practice in the normal way and in this interdisciplinary middle school way. And I just call your attention on the 2 first lines. We asked them if they comparing their previous practice in a single subject with their current 3-subject practice with the method I described for 2 items, for more, but I just comment on 2, working as a team and practicing interdisciplinarity. And you see the difference. Before, it's about 20% who did, this is significant. I think we work with 100 teachers. And after being forced, of course they were accepting it too, but to change their practice, you see the score is completely different, 80%. So they have learned 2 very fundamental things: to work in team, they didn't, and to practice interdisciplinarity, they didn't. So one of them was speaking about climate change and from the point of view of physics or chemistry, while the other, using different terms, different reference, different formulas, eventually was speaking from the earth science or biology term, and the technologist would speak in other fashion. So this rupture number 2, this will be a long effort. I think it's a 10 years or maybe 15 years problem. And the thing we want to fight against is this one. You know, those are measurements published by the ministry on the continuous decreasing interest of students who are teenagers. And teenagers is, as you know, more difficult than primary school students along their 4 years of middle school. And their interest for science should grow up. I mean, it's the age where they should swallow everything and think of their future, and it's just the reverse. So this is the thing we have to change, and it will probably take a long time. Now, our 3rd rupture was to say we have to care nationally for the professional development in service of teachers. And for this, we created, since it has almost disappeared and had, of course, a catastrophic impact on science education, our experience previous told us that this could change, but it was a great effort which had to be organized. And the ministry was not denying that it was not organized. They said they had no money, and they were using the very little left just to transmit orders. You should do this and that, and we have the problem of violence or citizenship or terrorism or the Islamic scarf and so on and so forth. And so the very little which was left in the school was used for those instructions from the ministry, but that was not what we consider as important. So we created 9 houses for science in the service, at the service of teachers. And the important word there are 2 important words, 3 maybe. House, teachers should feel comfortable at home, cozy. Science, of course, and service. We were not them to teach the teacher what to do, which is normally what the ministry has to do, but to help. And we created those prototypes with the hope that someday they would be taken by the ministry and cover France in 9 universities. The basic idea was every house has a partnership between scientists, engineers, and pedagogues. And it has to be balanced 50-50. It cannot be just a lecture on pedagogy of science. It cannot be a lecture on science and engineering only. And the goal is ambitious because we process, in a sense, about 7,000 teachers per year, and the program is funded for 7 years, or maybe 8 years. And this is continuously assessed. So here are where they are located over France. And you see the numbers. An interesting thing is the rate of scientist participation. And this is increasing, and today we reach, in all those houses, an average participation of scientists, researchers, engineers of 60% of the total persons who take care of the teacher. So this is very promising because, as we had experience with La Main à la Pâte in the previous years, the scientific community is very responsive, but this has to be organized because their time is limited and they cannot come and without knowing what they have to do. But once they are there, they are extremely helpful and communicate to teacher not tricks to do some lecture in the class or to give ready-to-wear material for the classroom, but to communicate the spirit of science, the process of knowledge, all the points which have been made before. So this has, hopefully, this is now producing some model for the future. We don't know if what will be the next step of that, maybe more covering France, but you can see how diverse the program is. It's regulated centrally by the foundation to avoid that things go weird. I should have said that it was profoundly inspired by the National Science Learning Centres in the UK and John Holman, and we owe him and his centres a great debt for having shown to us what they were doing and given us many ideas. So you see it covers many subjects which are done in a hands-on or inquiry way with the teacher, of course. Now, what about assessment? Of course, this is a critical point. We have had a number of impact on curriculum, like this year reform I was mentioning, teacher training. We have had a great impact on the media, the press, the radio, the television, the parents, and also the policy, the parliament. Many reports from the parliament on science education are referring to La MAP effort, which was important for the academy because the academy has no power. Nothing of what we have done has been enforced by decrees, laws, instructions from the ministry. So we feel that we have reached the goal that children first, teachers, parents, and the society in general see that science education done in inquiry is valuable because it makes the teachers happy, the students happy, and obviously you learn better when you are happy. It doesn't mean they make zero effort, of course, and this has, in a sense, ensured the reputation and the continuation of the effort. And we have a very simple thermometer on that. The website, which offers free resources, it has been now duplicated in a number of languages, but this website is consulted about 3 million consultations every year since now almost 10 years. So there is a continuous interest, and by teachers, of course, there is a continuous interest of teachers for science, and this is exactly what we wanted to achieve. There are more specific assessment. I don't go on that. Research on teacher practice too. So we don't have those nice assessment with statistics, error bars, and so on. We will have some of that for the House of Science because this has been part of the program. It has been very well funded. So we expect next year the result of that. We have more developed in the spirit of Win Harlan's thoughts, the formative assessment of teachers to give them continuous feedback of what they do in the class. So a few words now on the lessons from international cooperations. Those cooperations have been very broad with many of you, and I insist on the word cooperation. It's a win-win or real partnership. And for example, in 2014, I just have the number, we have held training sessions in 6 countries for over 600 trainers in various languages. So this has worked very well. It gave us the opportunity to measure how science is universal. Even in countries where the communication is not so easy because of language, finally, trainers and the training people from LAMAP understand themselves very well because they are facing experiments which are, nature is the same for everyone. We have this international seminar. Some persons present in the room have participated, which every year accept about 50 persons from various countries. You see the share of each country or region in the attendance, and it has accepted over 300 persons over those 7 years. So it becomes a kind of yearly event, which is very nice. And you see Yves Quéré, who was the 3rd co-founder of LAMAP, in front of the Eiffel Tower with some of the attendants last year. Now, we are trying, of course, in our own country and other countries to help moving a country to IPSE. This can be done in various ways. Maybe the most important lesson is that when there is no scientific institution which can relay training, it doesn't work. It's very nice, but it lasts 6 months or a year, and then it fades away. So this is the important role of academies, but many countries, especially in Africa, do not have academies. And this is why we are very happy that ISTIC has motivated, as we will hear tomorrow with Olivier Chong, UNESCO to push the governments, not only the academies or the scientists, but the governments to have plans to implement whatever is learned from those training sessions into the system, because that's absolutely the key point. Of course, regional cooperation is very important, like the European program, which was mentioned by Anna Pascucci, Fibonacci, and others. Now, I will finish in the 5 minutes I have to question, can we continue school as usual? There are several reasons for which my answer is no, we can't. First of all, the youth is changing, and not necessarily in an easy way. Children are 2 billion in today's world, a quarter of the population. 1 billion, half of it, has poor schooling. Over 100 million are completely out of school. How can one cope with that? Of course, there's this idea that students may teach each other. This is something I believe that IPSE has to explore much deeper than we have done in the past. We have mentioned that several times, but we have not explored it, organized it as we should, especially for those poor children. This is this idea of critical agents of change, which you find actually in the UN Sustainable Development Goals. I even gave the page 51. Now, the other change of the youth is, of course, their global connection. At the Vatican workshop, which was mentioned before last November, we called 20 students from 12 countries, refugees camps, immigrants, so on, to make a statement on what they thought important to make climate change challenges and environmental aspects more efficiently dealt with schools, including, of course, science education. We were absolutely surprised by the quality of their proposals. Their brain clearly had treated the problem, and of course they said in school it was generally not treated at all, except a few exceptions. So this was very impressive in this idea that with this changing youth, which in many cases is more mature, younger, one can change things. This has been worked out in a much more elaborate way by Joachim von Braun from Bonn University in Germany, and I recommend the reference of his work with a number of organizations in India and Africa. Now, the second thing which is changing is climate. And if one reads this agreement signed at the end of the COP21 in Paris last December, you see parties shall cooperate in taking measures as appropriate to enhance climate change education. Of these steps with respect to enhancing actions under this agreement. Of course, the Paris Agreement covers many aspects. Some are economic, some are industrial. But the countries, the people, they have to accept it. And this is what education only can achieve, because no dictatorship will be able to achieve that. And education for climate change requires many new things which are more or less already present in IPSE, like understanding difficult issues of science, like complexity, introducing interdisciplinarity, and this is a big ideas, and also question of ethics. So this has to be worked, I think, if we want to expand IPSE into a more broad education for sustainable development. This graph shows that the climate change awareness in the global public is very uneven between various countries and not very high. So how would one hope that the people in a democratic country would change their attitude if they are not aware of the basic scientific facts which are behind the proposal for change? So this gives the magnitude of the challenge for the next generation. Those kids who are today in our schools, they will be the ones in 2040 or 50 who will either suffer or hopefully act to change. La MAP, we have begun to address this issue with the climate, with the ocean, but I heard today that there were many other actions which were addressing this. We have published the most recent one, the ocean, in English. Those are teachers' guides just to try to fill this gap. This is an example of an IPSE activity on solar energy for 10 years old students. an interesting thing there is to make classrooms to cooperate the world over, because climate is a planetary problem, it's not a country problem. So you see there are today 17,000 classes working together in a network that David Wilgenbus from La Main à la Pâte has organized, and this is increasing all the time. Now, I'd like to also raise a question on IPSE. Are we sure that IPSE, as we define it, is adequate for the poorest of the poor? And I have mentioned those huge numbers of children. So isn't it at this point that science education has to be more intimately connected to education in general? We have, so should one think of a basic, absolutely basic IPSE for poor and rural areas tailored specifically? Refugee camps. The number of refugees, including so many children, has doubled in the 5 last years, not only in the Middle East and also in Africa. Migrants, there are 200 million of people who live outside the country of origin and their language. So can one think of a basic IPSE which would deal with rural issues, water, light, seeds, tool, and connect it intimately to the other learning issues like language and counting and socialize and so on? This is a question. I passed that. We are trying some of that experiment in Haiti with a project after the earthquake, also in Mali, where we are trying to connect scientists, they are in the Fondation Mérieux, with who has a research network called Gabriel. And in many countries, we are just beginning an experiment in Mali, as this picture shows, to have a relation between health, education, and basic science. This is another example, similar in Madagascar, where primary teacher, I would say even barefoot teacher, are beginning to do some science. So those new issues for IPSE are the ones I wanted to raise in conclusion, and I would say that school as usual is really not the thing that we can afford to continue. I had some other comments which I will stop there. I simply like to emphasize again what has been said today. Nothing of what we have done, either in France or in collaboration, could have been done without the scientists, Bruce Alberts, Mario Molina, Manzoor Samrou, Jorge Allende, of course. They all have played an absolutely critical role. And now when I go to a new country, the first question I ask, who is the scientist, the man or a woman, who will help us to start something in your country? Thank you very much.